Notice it says greater than 5 rem but less than 100 millirem per hour at 30 centimeters. Okay, remember if it's over 100 mR per hour, then we have to put high radiation area. So 100 mR up to 500 mR. Sorry, 500 R, I mean. 500 R, they put grave radiation area.
Mr. Adkin, 2 questions.
Yeah.
Okay, so I know this is University of Arkansas, but are there different, like I know like for, I don't know, different states and stuff that have different regulations. Is there anything that we shouldn't be studying off of the University of Arkansas that is different for California, or is everything kind of the same for nuclear medicine everywhere?
It's the same for nuclear medicine everywhere. See, California is what they call an agreement state, so we still have to adhere to the national laws. And so your board exams are all based on nationals. It has nothing to do with California. Remember we talked before about plus or minus 10% for an acceptable level? Okay, in California it's plus or minus 5% for consistency. But that's only in California and Maryland. So on a board exam, if you put down plus or minus 5%, that answer would be incorrect. Because your national board is just that, based on national licensure requirements. But
So
like
are they going to do something like that to us?
Yeah, absolutely. I mean, California is probably the strictest as far as any state. But the problem is, our standards are a little bit different. So that's why when you have a state inspector come to your facility, he's not going to be looking at that plus or minus 10%. He's going to be looking at plus or minus 5%. Okay?
And my second question is this, I've seen these papers and stuff that you've given us, so is that like a good study guide as to where we should really direct all of our studies?
Yeah, this thing that
because it's kind of bulleted, right? So it's like point by point by point.
Yeah. This is actually one of the best summaries for your studying for boards, and also Ann Steve's.
Because I know that one of the techs, Kim, she said that she used the University of Arkansas and Ann Steve's and just went over the questions and the study guide like crazy, and she said she passed her NHPCB, no problem.
Yeah.
But
well,
she's also a very smart girl, so I don't know how accurate that is for somebody like me, but...
Well, no, it's not so much studying it. The question is understanding it. That's the big thing here, because, when they ask you a question, we're going to be talking a little bit about, like, package readings, things like that. You have to measure it at the surface, and you have to measure it at 1 meter. Okay, so if you get one reading at 1 meter and another reading at, the surface, what type of label do you need to put on it? And what type of classification is that package? Okay, and that's why I said these signs are always, 100 millirem but less than 500 rads. Because remember, over 500 rads, and is considered grave radiation danger. I'm sending nasty things to her. Oh. Okay. Okay. People are watching videos rather than my highly entertaining.
You said this was, you gave us an email, right?
Yeah.
And
I think we got this last quarter in an
that's
email.
what I said too.
Yeah. Well, okay, so anyway, so you know what kind, this one tells you the kind of posting, and again, when you guys have a state inspector come in, they're going to be looking for signs. They're going to look at, when was the last time you guys did a survey? So, every day you're supposed to do a survey, okay, and then every week you're supposed to do wipe testing, okay, and you're supposed to do wipe testing of your packages when they come in. You're supposed to actually do surveys of your hands, feet, and body before you leave each day, or before you leave the department. I don't know how many people do that. But then this is the other thing here, okay, so you have radiation posting in your rooms, posting of signs on patients that are getting therapy. You guys all done that? Okay, you know what signs to put up there. You know how to calculate how long a person can stay in the room. If you remember, visitors and nurses are considered non-occupational people, so they're only allowed 2 MR dose. So they can only, you have to calculate how long can they stand either at the door or next to the patient and get a 2 MR dose. This packaging, the labels and things like that, what has to be on there, now who the 2 organizations that regulate it, Okay, the NRC and the DOT. You should know the difference between a type A package and a type B package. Everyone know the difference?
Type A is under,
And remember, you've got 30 seconds per question roughly to answer, but what is a white one, what is a yellow 2, yellow 3, and you should know what they look like.
What's yellow too, like pet, FPG?
yeah,
Now,
That would
well,
be
it's
three.
131.
okay, you guys, this is it here. It doesn't have anything to do with the radionuclide. It has to do with the radiation readings are. So surface cannot exceed 50 and exposure at 1 meter is 1 MR per hour. And under no circumstances can anything ever exceed 200 MR per hour. If you guys get a surface reading of over 200, that means there's probably a broken vial on the inside of your package.
You never get a yellow 3, right? Ever?
Oh, if you get
Is it
I-131,
I-131?
yeah, you might. If you get a therapy dose of I-131 and some other stuff. But this is your maximum limit. In other words, anytime somebody ships this stuff to you, it has to be under these levels. Okay? But again, on your board exams, they're going to tell you that a package measures this amount, and so what type of labeling should it have? You should also know what the transportation index is. Okay, and that's your radiation reading in 1 meter. But like I said, this thing here I think is an excellent study guide. So if we kind of take a look here at, okay, this is one of the handouts that I sent to you here, okay? We're going to kind of talk a little bit about this one. Did Terry print that one up for you?
I'm sorry?
Did Terry,
This one?
yeah,
Yeah, we had that one there.
okay. This is actually sort of a summary that goes along with this stuff that we're talking about right now, and also with Ann Steves. One of the things that you should be aware of is that let's talk about the different agencies that we have. We have what we call recommending agencies, and we have what we call enforcement agencies. And that's in the handout that I sent you. One of the recommending agencies, again, these are the ones that tell people what the law should be. We already talked about the International Commission on Radiological Protection. Okay, that's a recommending agency. We have, well, let's see here. I'll just take this one here, for example. Okay, this is one of the handouts that I sent you here. Notice that the regulatory agencies are responsible for formulating risk estimates, somatic and genetic effects, and that's basically what the definition of risk is. What is the likelihood that you're going to get cancer, cataracts, or genetic mutations? Okay. It's not in here. It's in the handout, so it's okay. But the agencies, and again, the ones that, these are all people that make recommendations. So the IRCP, the United Nations Scientific Committee on the Effects of Atomic Radiation, I have never heard of them before. The first time I heard of them was when I saw this published in one of the radiation protection books. But from my knowledge, I've never seen them do anything. I've never, it must be a good job.
That's what I say, I want that job.
Yeah, I mean, I want to go there and just sit on my butt and collect a paycheck and, look at the Manhattan River. Is that the one that goes by the UN? What's the river? Oh, whatever.
Hudson?
Is it the Hudson River that goes by the UN? That's a downward look. Now, here's an important one here. These guys are stationed up in San Francisco. NASBIR, National Academy of Sciences, Committee on the Biological Effects of Ionizing Radiation. These people actually send questionnaires to everyone that's licensed in radiology and nuclear medicine on a periodic basis just to see if you're still alive. I got my first one back in about 1980. It was a huge questionnaire. They asked everything about your personal history, what kind of foods you eat, barbecue, everything. No, seriously. What they're trying to do is that they're actually trying to look at a large group of people who are exposed to radiation to determine what the actual effects are. So, and I got one questionnaire about 2 years ago, and you know, when you get to be my age, they just ask you, are you still alive? It's kind of sad, you know.
And no food.
Kind of like, no, they have like, what's your age group, you know, from 0 to 5, and then, you know, I'm in that last column now, so, you know, what happens after you get over that, you know, I guess you're off the page. But,
Send in the chair.
yeah, send you a condolences letter or something. But anyway, but NASBR is a very active group that, you know, is in this thing. The NCRP, these are the guys that you have to have their books in your nuclear medicine department. I can't remember all of the titles that you're supposed to have, but there's a bunch of them that the state comes and looks for when they inspect your facility. Now, things like exposure for I-131 patients, radiation protection for high energy radiations. They have a bunch of books that you're supposed to have in your library. But anyway, these are the people that make the recommendation to the NRC, the FDA, and everybody else that has anything to do with radiation. Now, here in California, we have what we call the RTCC, the Radiologic Technology Certification Committee. These are the people that actually make the laws for California. They meet twice a year, once up in the Northern California area, and once down here in Los Angeles. Unfortunately, they meet on Wednesdays when we're having class. But it would be really good for you to go down there and attend one of the meetings. So maybe, you know, sometime in the future if you get a chance.
You don't have to be a member of them?
No. Anybody who works with radiation can go to this thing. And they do have public comment periods. A lot of the laws that affect radiology and nuclear medicine were discussed and formed at this committee. Okay? So it's a very, very important committee. The regulatory agencies. Remember, the NRC controls fission and fission byproduct materials only. They have nothing to do with your PET. Okay? PET is totally a state phenomenon. Okay? The thing that you need to be aware of is Title 10 of the Code of Federal Regulations. And then, as I told you before, Title 10, Part 20. So if you go through, if you ever look it up on the internet, if you go to Part 20, it tells you about all of the regulations regarding occupational exposure. Doesn't it sound like fun? I am not going to torture you the way that they tortured us when we were students. We actually had a guy sit here in class and read the regulations, one at a time. Sit there. Section 5554413 states that you da 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 da. Section 5543-2 reads. I mean, that basically that was our class for 3 hours. You know, and the guy was very monotone. And, you know, at least sometimes I think I realize when I'm getting boring. A little bit.
And
Not much. Okay. But anyway, so most states have an agency to provide the services, the NRC, called an agreement state. Okay, California is an agreement state. So we can't exceed the federal guidelines. You know, right now the federal guidelines say you can't get more than 5 rem per year whole body exposure. You know, California can't just come up and say, hey, you know, we don't think that's enough. Our techs work harder than anybody else. They should be allowed to get 10 rem per year. It's not going to happen. You can't exceed the federal regulations, but you can have them less than the federal regulations. So California can say, well, we think that 1 rem per year is, you know, is better. So nobody can exceed 1 rem per year. Okay. So that's an agreement state. Then, you know, because that the California has, this is our enforcement branch here. A lot of times the NRC will come with them on a state inspection. So if you're getting your facility inspected, you're probably going to have the state and the feds with them. Whenever they do a joint commission inspection of your hospital, they definitely have the NRC with them, as well as the state. So what they typically look at is when was the last time the facility was, investigated, and if, if you're up for a joint commission inspection and you haven't had any violations, they'll probably just come with that. By the way, anybody up here, Ashley or Sting, have you guys had an inspection either by the state or by the joint commission?
Never.
No, I've never seen one.
Well, here, a couple of years ago, they had these unannounced inspections, and almost, probably about 12 of the facilities in this got hit. Whoops. I know with the, I've got about 21 facilities with Charles Drew, and I would probably say 7 of them got inspected, and quite a few of the Loma Linda ones got inspected. And again, it's what they call a surprise inspection. So you're not going to get any notification. Okay? If they're nice, they'll call you and say, hey, you know what, next week we're going to be out to your facility, so at least you'll have an opportunity to clean things up. But when they come in on a surprise inspection, you're basically on your own.
But I heard that you can avoid, if they come surprise you, you don't let them go to your hot lab. Because they say that California rule, you have to get a visitor film badge for them. But because they come surprise, so you don't have it available, so they have to stay outside. That's what happened to me.
Let me just warn you, I would not tell them that.
My hospital did last time, so they have to stay out.
Yeah, normally that sets up a red flag. They'll probably get inspected every 6 months now for the next 10 years. They don't get mad, they get even. Usually it's just a lot better, I mean, the main thing, when they come in, they don't want to see that your doors are open and anybody can walk into your department, especially the hot lab. They want to make sure that you have the signs posted on the outside, etc. And the main thing, make sure that all of your quality control stuff is up to date. Like I said, what I would like to do is, since we have very similar topics for both the PET and for your review, I would just like to kind of do it like that. So after we do radiation protection, I'd like to do patient care next, because there's a section on patient care in Ann Steve's and also in the PET book. But anyway, the other agencies that do regulation, that do enforcement, EPA, Environmental Protection Agency, and these people mainly have to do with dumping radioactive waste, things like xenon, burial, that type of stuff. Remember, you have to know how to dispose of the radioactivity. You can put it in the trash when it decays to background. You can incinerate it. You can bury it. You can flush it down the sewer, provided that you have calculated, what the water flow rate is. But the FDA, the FDA actually is more into the regulation of X-ray equipment now. But they still monitor things like xenon and stuff like that. OSHA, and also Cal OSHA. Okay, both of these people, to make sure that you have the proper protection, shielding, forceps, long-handled forceps, syringe shields, things like that. If you don't have that information or that material, you can tell your boss you better get it, or I'm calling OSHA, because they will make him get it if he doesn't, And then lastly, the radiation safety officer. He's your enforcement in the hospital. You guys all have radiation safety officers. One of the first things that you might want to do when you go to a new site is, find out who the radiation safety officer is. Sometimes they don't know who they are. Who's your radiation safety officer? Oh, it's a John Radke. So walk over to John Radke's office and, Mr. Radke, I'm here. I hear you're the radiation safety officer. I'll say,
What?
I am? I didn't know that. Okay, but he's the person in charge in the hospital. Okay. So, moving along here, we're going to take a look at Ann Steve's here. Okay, so these are some of the byproducts, fission byproducts that are under the regulation of the NRC. Okay. These guys down here, remember we talked about, these are part of the radioactive series. You typically don't see actinium used for anything as a fission byproduct, but uranium, thorium, and plutonium all fission And as a result of that, there are radionuclides that are used from them. 238 uranium has a lot of radionuclides, 235 uranium has a lot, but these guys, ones you can make bombs with. So, and moving on down here, okay, the state jurisdiction typically has responsibility, and again, if you don't have a state licensing board like we have in California, then you're going to have the NRC that you have to report to. You understand? So, if you're in a non-licensed state, and there's typically about, I want to say about 18 of them left, then the NRC is your people overseeing you. But as I say, here in California, we're a licensed state. We have a Department of Health. We have a radiologic health branch. So these people are the ones that you have to buy a license to have a radioactive material license. Remember we were going through that? On your radioactive material license, remember you had to tell them how much you have that you order on a daily basis, how much you have in storage, and how much you have in decay. Because that's what they base the charge of your license fees on. Okay. The more you have, the more money they charge, the happier they are. So then they don't have to be on furloughs anymore. Okay. And again, they want to make sure that you get the receipt and how you dispose of it. You guys all done that? When you guys send stuff back to the radio pharmacy, or you let it decay and throw it out in the trash? Okay. Okay, so then any cyclotron-produced radionuclides or positron-emitting radionuclides, anything that comes from that type of a particle accelerator is considered a state issue. Okay. Now, and again, this is all in and Steve's, but so the next thing is agreement states. So again, they're going to accept responsibility for all NRC regulations. And typically, I think the state does that because they can charge and make money for it. Okay. Now, the only thing that is not regulated here in California are the VA hospitals and military hospitals. Okay, those are not. Well, I shouldn't say that completely, because in order for you guys to get a state license, if you train at a VA hospital, the VA hospital has to meet the same standards as any other California hospital. But if the VA says, no, we don't want California, or we don't care about California, they basically have their own standards that they, you can do brain surgery there if you want. Yeah, actually, they used to allow their, like orderlies and people, janitors to train as, radiology, nuclear medicine, whatever. Let them in, seriously. Okay, but those things are not.
You're not allowed to go in there?
Yeah, well, actually, one of the former students here, Andrew Heiss, he graduated from here. He was in my class. He's the director over there.
I thought, isn't it a lady?
I know that Andrew, unless he retired.
Yeah, it's a lady like in her late 30s or something.
Oh, maybe he retired and went somewhere else. But he was working MRI here for a while too, and then he went over to the VA. So, okay, then the next thing, you guys have already seen this. If you remember, when we were going through the faculty license. If you guys go to the California website, you'll see the radioactive material license application. And one of the nice things about, going and inspecting facilities is all I have to do. I used to go to hospitals and make sure that they were in compliance, especially my training facilities. But all the stuff that was on here, like, the name of the facility, the address, because that's where the radioactive material has to be used and shipped. The doctors tried to get away with shipping this stuff to their imaging centers. They'd ship it to the hospital, they'd pick it up and take it to their imaging center and got nailed for it. The radiation safety officers and physicians, remember I told you to check that? because you may have doctors on there, one group comes in and another group goes out. And, one hospital up in San Fernando Valley, there wasn't a single doctor who was on the radioactive material license. Okay, so that was a problem. Radiation safety officer, the well-established uses, this basically tells you how much you're allowed to use for each type of study. So as you go through that, tells you what you're allowed to use. And then anytime you exceed that amount, you have to file an amendment. So like if you're doing bone marrow studies, you have to make sure that you have an amendment that says we can inject 12 millicuries of sulfur colloid for bone marrow imaging. And that also means that it has to have gone through the Radiation Safety Committee, so you justify why you're doing it. Okay. We talked about the different categories of radionuclides. Remember, this is what they're going to charge you based on how much activity you have on hand. So these are the different groups. But anyway, one of the things that I did want to kind of get to, we talked about the ALARA program. That's always a big thing. Remember, what does ALARA stand for?
As low as reasonable.
Okay, so if I went to Cynthia's hospital and I said, Cynthia, what do you do for ALARA? And you tell them, well, I sit here and hold the patient hand while they're scanning. They're probably not going to be too happy about that. But if you have programs where you talk about calculating the dose precisely so that you get the smallest amount for your patient and things like that, what you do to protect people, you have classes for the nurses so they know what radiation is and you protect them and things like that. The Radiation Safety Committee, like I said, if you guys go through your hospital license, all that stuff should be spelled out. Who's on the Radiation Safety Committee, what doctor knowledgeable with radiation, what administrative personnel is on there, who the radiation safety officer is, who the director of nursing is. Those are the 4 people you absolutely, positively have to have on a Radiation Safety Committee. Okay.
I had a question a little bit earlier.
Yeah.
With the hospital that Sang and I are at now, they don't, they do their stress tests and cardiology is a completely different department than ours. They have to walk over and do it. Should they be surveying that once a week or every day?
Anytime they do a study, they should be surveying it. I will tell you that many of our hospitals got burned for that very same reason. They put them on the treadmill over there, they did the EKG, they did whatever, and when they inject them over there and then bring them over to the department, that area has to be monitored.
And even if it's a Lexus scan as well?
Oh yeah. Any place where you're injecting radioactive material, it states in the license that it has to be monitored. And what we were able to get away with is we tell them we monitor them after each patient. So we go over there and monitor the cardiology department after a stress treadmill, just to show that it's okay.
So then for inpatients, when you do like a Lexus scan and you're injecting in their room upstairs,
Still have
you're
to
supposed
monitor
to
it.
monitor it.
Yeah. Yeah, any place where you inject, you need to monitor it after you're done, just to make sure that there were no spills. And remember that little survey thing that I showed you guys of the diagram of my department? That I also had a little section that says monitoring the bathroom that we use for our patients, and also the cardiology stress lab. So, I mean, normally when we were doing a Denison or Lexus scan or anything like that, we did that in the nuclear medicine department, so it wasn't a big deal. But, yeah, anytime the treadmill. And then, like I said, this is just the duties of the Radiation Safety Committee. We talked a little bit about that. You're supposed to meet on a quarterly basis. And
Definition for that, less than 16?
well, it says less than 13 and no more than 15 weeks, something like that. The state has an actual definition for it, so. It says, the radioactive material, the Radiation Safety Committee shall, now, there's a shall and should in all of the law statements.
One is
Shall means that you better be doing it.
must.
Yeah, it means you must do it. Meet as often as necessary to conduct business, but not less each calendar quarter. Then you have to have a quorum. Okay. Okay. Anyway, moving along here. We talked about the required instruments at one time. Remember, again, you're going to see these instruments again in chapter 7, I think, of the PET study guide. Okay. So they're going to be talking about Geiger counters, survey meters, and also PET scanners. And we'll be talking about PET scanners a little bit later here. That says for group 1 and 2, you have to have a GM. Okay. For multi-dose or a generator, then you have to have a high-intensity survey meter. Remember what regions those things operate in?
First one's the GM region.
Okay, the GM region. What's the multi-dose high-intensity survey meter? What region of the curve does it operate in?
The one after that.
The one after that?
Before it.
The one before it?
Oh,
No.
it goes like,
Oh, the one. Okay, what comes after the GM region?
See?
Continuous discharge. So you can't use that region. The one before it is the proportional region.
that's.
Oh, yeah, the
neutron.
one after continuous.
Fluorine, trifluorine.
No, after continuous, you burned up your tube. What's the first region?
The ionization,
Ooh, no,
saturation.
No.
Three.
it's not the first one.
Ionization, saturation's the one at the end, right?
The
No.
beginning.
It's in the beginning. The first one is recombination. Okay, that one we can't use. The second one is ionization or saturation region. Okay, that's the one that most of our detectors operate. The high intensity, the survey
Those
meter,
calibrators.
those calibrators, ionization, the pocket dosimeters. Okay, all of those work in that region. Okay, and it's a plateau. Okay, you don't want to have any slope on that, because remember that shows that the gas or the instrument is not working properly if there's a slope of more than 10%. Okay, so make sure you understand what you use it for. So for group 1 and 2, the GM for multi-dose, which is most of us, and for generator or therapy, you have to have a high-intensity survey meter.
And that one operates at ionization saturation.
Yeah. First one is the GM region, and that's the one just before the continuous discharge. So
So
it's
the order again, what's that?
okay, recombination, ionization, or saturation region, proportional,
Oh,
GM,
that's the one I was forgetting.
GM,
And what's the last one?
continuous discharge. Yeah, remember that's where the potential difference is so high, you're literally taking electrons off of the gas. There's no radiation being present. And normally that burns up your tube very quickly. And remember, some people will self-calibrate their equipment, and you turn that transformer up too much, and yeah, howdy, you'd be buying a new one. Okay, then the dose calibrator, we're not going to worry about it for radiation safety right now, but we will come back to it, and we will look at the quality control of your radiopharmaceuticals. Okay? Again, the same thing with the calibration of instruments. You might want to pull this thing out so we can have it available. Okay, so the calibration of instruments, which is again a radiation safety thing, because if you don't do it, you don't know your equipment's working properly. You could be in the middle of a radiation field and not even know it. Okay, this is again. It's the one that says radiation protection, California radiation control regulations.
We got that one last quarter, yeah?
Yeah.
Is it new?
No, it's one that you had from last quarter.
Okay.
Actually, I think it was the second one, second quarter.
Yeah, maybe it's better.
Yeah, because that's when we were talking about instrumentation. But but it's got a lot of quality control stuff in there that we'll go through again, just as a reminder, spec quality control. A little bit further on, okay, we talked about facilities and equipment. This is something, you have to have a diagram of your nuclear medicine department that shows where shielding is, and identify areas that you've done surveys on as to whether it's an unrestricted area or a restricted area or high radiation area, things like that. So you have to be able to show that you've done that, okay? At least on an annual basis. You have to do all of you guys have fume hoods at your facilities? Okay, have y'all ever monitored them? No?
You mean like a white test or?
No, not a wipe test. You have to monitor the airflow because you have to show that there's 100 cubic feet per minute.
Oh.
Okay? And you have a device called a velometer. You know, basically it's like a hot piece of wire, and as the air cools it, that's how it's able to calculate what the airflow is. You don't want to touch the end of that puppy because it's red hot. But that's what I'm saying here is airflow rates shall be tested at intervals not to exceed 12 months. So that means once a year you have to test it. Any repairs that affect the ventilation system. Also use that velometer to calculate whether or not you have negative pressure on the inside of your room. Okay? So remember, you have all those vents in the ceiling, and you measure the outflow and the inflow. So the inflow has to be greater than the outflow, or the return back into the room. Otherwise you don't have negative pressure. And you can't use xenon then. It says, notice the fume hood. Now again, these are questions that are legitimate for your board exams. Okay, when do you need a fume hood? When you have liquid iodine and you have xenon. Okay? Because remember, liquid iodine is very volatile. Okay, it's not stable. So as soon as you open the vial, you better hold your breath. I think most facilities have special dispensers now, but like I said, I talked about how hard it was in my day. You know, we had to walk to the nuclear medicine department through the snowstorm, and it was uphill both ways. Your parents ever tell you that one? Yeah. I used to have to go to school. It was 2 miles, and I had ice in my hair and holes in my shoes. Yeah. In my day, it was, well, I had to drive a 1965 Mustang instead of a, BMW. So. But anyway, so that's one of the things you have to do. Okay, so every 12.
Is that why they have to monitor, if you handle liquid, you have to monitor inside it?
Yep. You have to do a bioassay. What they typically do, if you handle liquid iodine, they do an uptake over your neck, and they monitor your urine. They get a pee sample and a uptake over your
Why
thyroid.
does it go to your thyroid?
Huh?
I mean, doesn't it decay into something else?
What does it decay into?
Never mind, I remember.
Xenon. It decays into xenon, 131 xenon. But so we won't worry about that. But the problem, though, is that yes, if you use liquid iodine, then you're required to get a bioassay. And remember that when you take iodine in, it all gets absorbed, but 30% goes to your thyroid and 60% goes out the urine. 10% stays bound to your proteins in the blood. That's a typical breakdown of it. Okay, personal training programs. Now, here again, they have to document that they gave you an orientation, and did you guys all sign some kind of an orientation form that you know how to work in the department and you know where everything is and you're competent and all that good stuff? This is something for when you guys become managers. Make sure that people are oriented to all this and that you document that they received the training. So you make a little book that says, okay, here's where we have the radioactive material, these are the hazards of radiation, the safety, pertinent California rules, okay, all this stuff, you go over with your personnel, you have them sign a little notebook or sign a form that they've had this training, and you're covered. Because if anything happens, and they say, well, they never told me about that, you're done. If somebody gets contaminated, and, you know, they think they're gonna get leukemia, they sue you, you're probably, you know, messed up. Another safety issue, procedures for ordering and receiving radioactive materials. Those usually have to be posted or somewhere available. Strongly suggest you post it somewhere not in the radiation hot lab. Okay? All of your procedure manuals and things like that should be located in an area where if you had a spill, somebody doesn't have to go in there and get the book to find out what to do. Does that make sense? Yeah. Phone numbers for like the radiation safety officer, it's a good idea to post them on the outside door of the nuclear medicine department so somebody doesn't have to go in there. Okay, but anyway, so the thing is, receiving radioactive materials during off hours, notifying persons, blah, blah. These procedures should be average, your possession limits are not exceeded, materials are verified and checked. And y'all remember, how long do you have before, when the department opens, to do your verification and everything?
30 hours.
Huh?
30 minutes?
No.
1 hour.
An hour or two.
Yeah, it's about 2 hours. Okay. Okay, and then again, these are just some other things that you have to have posted in there. You know, if you are not available, who and what training has the person received to receive these packages? So security personnel, nursing personnel must be issued written instructions as the procedures to be followed. Okay? So again, here's this, you give them an orientation, you have them sign a form that they understand what to do, and you're covered. Okay, another thing is for opening packages, again, this is all California radioactive material license stuff. Okay, put on gloves, visually inspect the package if it's crushed or damaged, or any signs of leakage of anything. Okay, if you see anything, you stop, you do not go any further. Measure the exposure rate at 1 meter first, and then measure it at the surface. You don't want to measure at the surface and then realize you just got a lethal dose of radiation. Okay, so make sure you measure it at 1 meter before you do anything. Another good thing is don't keep your survey meter like underneath the shelf that they put your radioactive material on when they deliver it. So in other words, make sure that your GM is located somewhere safe where you can turn it on and measure before you go into the room. Does that make sense? You don't want to turn that thing on and find out you've been exposed for the last 5 minutes getting blasted. Okay, then the package, remember we said should not measure more than 10 MR at 1 meter at any time, or more than 200 MR at the surface at any time. Don't care what they shipped you. Okay, you have to provide enough shielding for it. The Type A package is what we normally get our stuff in. That's the standard shipping packages. The Type B is for the really dangerous stuff. So the Type B is a lot stronger packaging. Okay, and those are Department of Transportation requirements. So Type A and Type B packaging. We get the Type A pretty much all
So
the time.
that FDG 18 is a type B then?
No,
Still type A?
still Type A. Yeah, I mean, they ship I-131, hundreds of millicuries of that in Type A packaging. I have never seen a Type B packaging, but that would be for something that is really radioactive. I'm thinking, when they do industrial radiography or industrial imaging, let's say that they're looking for cracks in an airplane wing or stress fractures in a metal pipe or something, they typically have a very high radiation cesium source, and they bring this container in and they put it underneath the airplane, and then they open it up, and first of all they put film all over the wings and everything where they're stressed, and then they expose it for maybe a couple of hours, and then they process the films and see if there's any stress fractures. But something like that would be a Type B. And there's companies around here. There's one actually over in Colton that manufactures stuff like that for industrial radiography. Or some of the sources that they use for sterilizing equipment. They use radiation and ultraviolet light. Yeah. Or, you know, when they irradiate vegetables and things like that to make sure that they preserve them longer. You know that? Yeah, a lot of the vegetables and foods that you get, they irradiate it to make sure that it's sterile and safe.
I have a question.
Yeah,
About when they ship like a generator.
that's still a type A. But again, it depends on the activity. Most of the generators that they ship are probably maybe a couple of curies. Yeah, they don't normally ship something really, really hot. But if they did, if they had like, you know, somebody that ordered I mean, I don't know what the limit would be, but if it was like a really, really high intensity generator, then, you know, they might ship it in a type B container. When they were transporting radioactive waste to Nevada, they were transporting it in type B containers. So, but again, so the packages and things like that, all of the times when you guys do your surveys of the stuff you're returning, you have to put down what the radiation readings are and things like that. And also you have to make sure that you're not exceeding the possession limits for the radiopharmacy. There was a time when when they discovered that the radiopharmacies were not authorized to receive radioactive waste. So that's when hospitals started keeping the radioactive waste on site.
Oh, yeah.
You know, we had radioactive, you know, the short-term and the long-term stuff. And the long-term stuff, you know, we would eventually transfer it out to a drum that we had in the parking lot. We had it roped off to where people wouldn't get more than 2 mmR per hour. Okay, the records of dosage and all this kind of good stuff here. Again, we're going to talk about doing some dose calculations. And I think I gave you that quiz on radiopharmacy, that first one from Ann Steves. I know you guys have been burning your books looking at it. Okay, but